my YouTube viewers. In this particular video, what we're going to do is we're going to discuss the difference between a parameter and a statistic. Basically, if it's a population, it's a parameter, and if it's a sample, it's a statistic. And I've got a little table on the screen for you to see the difference between the two. Okay, so while both terms are used to describe numerical values that summarize data, they have distinct meanings and applications. So you need to understand the difference between a parameter and a statistic because it's essential for interpreting and making inferences from data accurately. So a parameter is a numerical value that describes a characteristic of a population. The population refers to the entire group of individuals or items that are of interest in a particular study. Parameters are used to summarize data for the entire population and are often denoted by Greek letters. Some common parameters include a population mean is with the sign micro. A population variance is with the sign sigma squared. A population proportion is with the sign p. So we have characteristics of parameters. Fixed value. Parameters are fixed values that do not change because they describe the entire population. Parameters are often not directly observable because collecting data from the entire population is impractical. Instead, they are estimated using sample data. Parameters represent the true values and characteristics of the population. So now we're going to discuss the statistic. A statistic is a numerical value that describes a characteristic of a sample. A sample is a smaller, manageable subset of the population selected for the purpose of conducting research. Statistics are used to summarize data for the sample and are often denoted by Latin letters. Some common statistics include, you've got a sample mean, which is X bar. You've got a sample variance, which is S squared, and you've got a sample proportion, which is P hat. So we have characteristics of statistics. Statistics can vary because they describe the sample, and different samples can yield different statistics. Statistics are directly observable because they are calculated from the sample data. Statistics are used to estimate values of parameters and make inferences about the population. So we'll talk about roles of parameters and statistics in statistical analysis. Parameters and statistics play distinct but complementary roles in statistical analysis. In descriptive statistics, it involves summarizing and describing the main features of a data set. Statistics such as sample mean, sample variance, and sample proportion are used to summarize the sample data. In inferential statistics, it involves making predictions or inferences about the population based on sample data. Statistics are used to estimate parameters and test hypotheses. For example, the sample mean X bar is used to estimate the population proportion mu. And in hypothesis testing, statistics are used to determine whether there is enough evidence to reject a null hypothesis. Parameters represent the assumed values for the population, while statistics provide evidence from the sample data. So that concludes our talk about understanding the difference between the parameter and the statistic. So I'm going to go ahead and conclude this video. And the next video we'll be talking about some other statistical concepts.